Can you go and say them? Didn't form beta. Yes, Ruchi. Everyone, hi. See, last class we were discussing about in work and energy. We were understanding that energy is the capacity to do work, Hana. Energy is the capacity to do work. So work and energy are complementary of each other. In absence of energy, work is not possible. So definitely the work is exactly going to be done when energy will be present inside our body as an external source or internal source. Understood not? So many times when we are exactly throwing a ball, so when we are throwing a ball, how we are exactly going to throw a ball? We are going to throw a ball with the help of the energy that is possessed inside in our body. So that possessed energy inside our body will be acting as internal energy, will be acting as what? Internal energy. And this internal energy is going to act according to our storage capacity. So if we are having a very high level of energy, what is possessed inside it, we can lift anything and we can throw, correct now? So that also. So but there are two different type of things. There are two different type of things. One thing is it buffering? So please kindly see, is it buffering? Check, anyone, inform very quickly, is it buffering? No, it's not buffering, she's telling. Okay, fine. Inform in the group, class started and everybody has to start. Yes. So everybody has to join. Please kindly inform in the group. Everyone has to join. Okay. So now look here, beta. So this is exactly going to be one of the most important things. So our body can do work. So now we will solve some numericals based on kinetic energy and potential energy. So that there are two different type of energy. One type of energy is considered as kinetic energy and another type of energy is considered as potential energy. Understood now? The total work done can be the sum up of both kinetic energy and potential energy. So beta, where potential energy is the energy stored in a body due to its position. Understood? Like stagnant. So I kept something and that energy is exactly inside them. That is considered as potential energy. Understood? That is considered as what? Potential energy. And beta, then another segment will be there ki when I will be having motion. So when I will be having motion, at that time when I'm having motion, the energy that is exactly stored inside my body because of its motion will be exactly considered as what? It will be considered as kinetic energy. So there are two different type of energy. One type of energy is called as what? Kinetic energy, and another type of energy is exactly potential energy. So now we are going to see some numericals, and based on that numerical we are going to solve. So now what is exactly the question is, a body can do 40 joule work. Understood? What is its energy? So definitely work done is equal to energy. Understood or not? So how much energy is present inside the body, that much work it will do. So definitely if a body is doing a work done of, hello beta, a body is doing a work done of 40 joules, that means how much energy it is having? 40 joules. Understood? So beta, how much energy it is having, that much work it will do. So definitely it will be having same amount of work and same amount of energy it's exactly doing. So definitely work done here will be totally replicated as energy here. I hope you might have understood this one. I hope you might have got this point. So definitely work done will be definitely considered as energy here. I hope you might have understood this sections. So now look here. A body of mass 10 kg is moving with a velocity of 3 meter per second. What is its kinetic energy? Now what is the formula of kinetic energy? Based on the formula of kinetic energy, we will be solving the question. So here, what is the mass? Mass is equal to 10 kg. So mass is given as 10 kg. Understood? Now its velocity is 3 meter per second. So V is equal to 3 meter per second is there. So what is its kinetic energy? So if somebody will be asking you what is the kinetic energy of the body when mass and velocity is given. So when mass and velocity is given, then kinetic energy will be exactly equal to, kinetic energy will be equal to half into mv square. So it is coming as half into 10 into 3 into 3. So definitely it is coming as 5. So how much it's coming? 5 is a 15, 15 3 is a 45 joules. Definitely this is the amount of energy it is exactly having. I hope you might have understood. Huh? So this is exactly going to be, so kinetic energy is equal to 45 joules. What is the kinetic energy here? Kinetic energy is coming as 45 joules. So kinetic energy is a part and it is exactly considered as 45 joules. Very good. Kanishk has solved the question, that is half mv square. But answer also you need to type and say it is exactly coming as how much? 45 joules. So it is also solved it. So now we are going to go for the next one. Now next part, the kinetic energy of the body is this much. Now this time they have given kinetic energy. Now they see, if they will ask these type of questions, how we are going to initiate. Kinetic energy is already given. That means kinetic energy is given in the form of what? Kinetic energy is equal to, solve sham, kinetic energy is equal to half mv square. Now beta, kinetic energy how much given? 1800 joules. So we will write here 1800 joules is equal to half, mass is 9 kg. So 9 into velocity square. So first beta what we will do, we will shift this one this side. It will become 0, 0, 2, 8 just 16, 36 by 9 is equal to v square. Okay, so 9 fours are 36. So it is coming 400. So velocity square is equal to 400. We will take root on both sides. So velocity is coming as 20 meter per second. I hope you might have understood beta. So this is exactly, yes, absolutely. The velocity is exactly coming here as 20 meter per second. The velocity is coming here as, yes, the velocity is coming as 20 meter per second. So here this is exactly coming, so this part 20 meter per second. So velocity is coming as how much? 20 meter per second. So relation between kinetic energy and momentum. Momentum is mass into velocity. Understand not? So if somebody will be telling you how to generate relation between kinetic energy and momentum. So let's see. We will be solving. I will teach you how to generate relation between kinetic energy and momentum beta. Now, beta, we are going to generate relation between kinetic energy and momentum. Now look at beta, what we are going to do here is potential energy. First work what we will do here is so now we are going to talk about momentum. Momentum is denoted by rho. This is mass into velocity. Correct na? Momentum is equal to mass into velocity. Now kinetic energy is equal to half mv square. Understood? So now if I will write kinetic energy is equal to half into mv into v, so it will become kinetic energy is equal to half momentum into velocity. Understood? We can do like this. So momentum is equal to what? 2 into kinetic energy. We know that momentum kinetic energy is half mv square. So momentum will be exactly equal to this mass into velocity. So velocity part we are going to substitute. So if velocity totally we are going to substitute. Yeah, next question I am doing. Next question we are doing. So now what we are going to do here is we will check this one out. So now look at it up. Momentum is equal to mass into velocity. So one time that relation is there. One relation is like that. Another relation is that given momentum by mass you are writing, that will become equal to velocity. So now we can relate it like this. If velocity we are replacing. If what we are replacing? Velocity. First I replaced mass. Now here I am replacing velocity. Then what it will become? Half mv square. So m into, instead of v, we will write like this. Understood? So here it will come ke is equal to half m into momentum square by m square. So this and this will get cancelled. So 2m into ke is equal to momentum square. So this and this will be there. This is exactly there. Okay. So this is the answer. So 2m ke. So this is exactly going to be the answer, and this is a way to write the answer. Note down beta. So momentum is equal to 2m ke, and that 2m ke part is written like that. I hope you might have understood. Now look beta. This question everyone do. Now, shall we start this work? A body cannot have momentum. Understood not? A body cannot have momentum without having kinetic energy and vice versa. Body cannot have momentum without kinetic energy and vice versa. So now for a given body, if Ek is kinetic energy, then momentum is directly proportional to kinetic energy. Just now we have derived this relation. Understood or not? So what relation we have derived? What relation we have derived here is, now look here. So what we have learned is root under 2 into what we have got, mass into kinetic energy is equal to momentum. So that means momentum is directly proportional to root of kinetic energy. Momentum is directly proportional to root of kinetic energy. Understood? So this is exactly coming as root of kinetic energy. So momentum is equal to directly proportional to root of kinetic energy. So here for a given value of P, understood, for a given value of P, for a given value of P, when somebody will be talking you for a given value of P, M into Ek is coming as constant. So beta one by one I am going to show you and discuss. So I have already given you this part. Now I am going to discuss you this section. Wait just 1 minute. I'll remove this part and write. So look here. Now look here. When somebody will be talking about this, so a body cannot have momentum without having kinetic energy and vice versa. So when somebody will be talking about kinetic energy is equal to half mv square. Understood? So when somebody will be talking about momentum, momentum means motion of a body. So if a body is in motion, that means 100% it is exactly having kinetic energy. Kinetic energy is there means momentum is 100% there. Momentum is 100% there. So for a given body, if Ek is kinetic energy, what is Ek? Kinetic energy. Then P is directly proportional to Ek. Ek. For a given value of P, Mek is coming as constant. So here Ek is equal to 1 by M. Definitely that may just we have done. So now here P is given value of Ek. P is directly proportional to root under M. Definitely we did right now only now. So that means three things we have derived. First, though momentum is equal to root under, momentum is directly proportional to A. Momentum is directly proportional to root under kinetic energy. Second thing is momentum is also directly proportional to root under mass. Understood? So these are the two derivations we have done. So now two things are there. First is momentum is directly proportional to kinetic energy. Second thing is momentum is directly proportional to mass. So here momentum is directly proportional to kinetic energy and momentum is directly proportional to mass. So these two things are there. Understood? So now also we know that momentum mass into kinetic energy is equal to constant. So these three things we have derived. And from where we have derived, everybody please kindly type one time and say, first what we did, we wrote kinetic energy. Kinetic energy is equal to half mv square. After that what we wrote, okay, kinetic energy we have replaced velocity and we have written mv square instead of velocity we have written m by v, and after that what we have done, we have just substituted the value and written. I hope you might have understood this one. So it is given value of Ek and P is directly proportional to M. I hope till here it is there. Huh? Now first question we are going to solve based on this. So kinetic energy of a body of mass 100 gram is 80 joules. Find its momentum and velocity. Do it. Oh, can you solve? Can I do one more time? This one. Forty and four. You need to check kinetic energy of a body of mass is 100 gram. See, 100 gram given means you have to convert. Understood not? So kinetic energy of a body of mass 100 gram. So when 100 gram is there means 100 by 1000 it will get converted into kg. So it will become 1 by 10 kg. Understood? Is 80 joule. So kinetic energy is given. So this and kinetic energy is given as 80 joule. Find its momentum and velocity. So kinetic energy is also given and momentum and velocity. So only momentum and velocity you have to find. So once they will be telling find the momentum and momentum. So here you know that momentum is equal to root 2 into. So what is the formula for momentum? Momentum is equal to 2 into m into kinetic energy. So what it will become 2 into m is 1 by 10 into kinetic energy is given as 100. Understood? So this cancel, it is coming as root under 20. Root under 20 is 2 root 5. Root under 20 is 2 root 5. Okay? 2 root 5. Understood. So this is exactly so. mv is equal to p coming. Now v is equal to p by n. So this part when they will be telling that find the velocity. So momentum by mass is coming as velocity. So now momentum is coming as 2 root 5 now. Because here this much is there 80 is given, sorry, I wrote here 20. So this part is 80 joules, kinetic energy is 80 joules means now it is much easy. 80 joules coming here is 16. So definitely 80 joules means this 0 can, this is 16, 16 is given as 4. Understood? So once 4 is coming means it is exactly coming. So here 4 is coming. Now 4 will be written 4 by mass is 0.1. We can write like this also now. Velocity is equal to this because we know that momentum is equal to mass into velocity. Like this you write. Momentum formula is what? Momentum is equal to mass into velocity. Momentum coming is 4. Mass is coming as 1 by 10. So mass is 1 by 10 into velocity. So velocity is coming as 40 meter per second. Definitely. Velocity is coming as 40 meter per second. So what is the velocity is coming? I hope you might have done this one. Till here it is done. Understood? The momentum of a body of mass 2 kg is 100 kg meter per second. Find its kinetic energy. Direct answer, beta. Try this question. How much it is coming as? Let's see how answer is coming. Let's check this one out. So the momentum of a body of mass 2 kg. Momentum of a body of mass. Okay. So momentum of a body of mass 2 kg is 100 kg. So momentum given 100 given, body of mass 2 kg, and its velocity. First we will find velocity. So velocity is coming as 50 meter per second. Then what is its kinetic energy? Kinetic energy is equal to half into mv square. So half into mass 2 into velocity is 50 into 50. So how much it is coming? 2500. Check. They ask like this only, na? So first, what is there? The momentum of a body of mass 2 kg is 100. So momentum written, mass written, velocity coming out 100 by 50. So it is coming directly 50 meter per second. Once you have found mass, next what you have to do? So here kinetic energy is equal to half mv square. So when half m, mass is 2 and velocity is 50 into 50. So this is coming as 2500. Yes, did you got it? 2500 joules, beta. Unit you must write 2500 joules. So this is the correct answer, 2500 joules. 2500 joules. That's the correct answer. We'll go for the next question. Done? That was the question we have done. Now we are going to go for the next question. Work energy theorem states that for a rigid work, see now look here. We need to understand some another important point here. So if somebody will be asking you, work energy theorem states that for a rigid body, understood? The body is not flexible. The body is supposed to be rigid body. For a rigid body, work done by a force on a body is equal to change in kinetic energy of the body. So if any force is changing, understood? So work done, remember this, work done by a force on a body is equal to change in kinetic energy of the body, is equal to change in kinetic energy of the body, understood or not? So it is exactly equivalent to change in kinetic energy of the body. Now consider a body of mass m moving with initial velocity u. So one body is there, what is the mass? M, and its initial velocity is u. So what will be the force? The force is exactly coming, see, mass is m, initial velocity is u. Now force be F. Then what we are going to do? We know that force is equal to F times will be there S. Understood? So how many force means how much force you are exactly going to apply? Force into displacement is coming now. Force into displacement. Work done is equal to force into displacement. And another thing is Newton's second law of motion says that F is equal to ma. Mass into acceleration. So can I put there F is equal to mass into acceleration? So here instead of force what we applied ma. Understood? So now here when we will be writing about this one, we have just written that V is exactly what MAS is there. Understood? Also V squared minus U squared. Why it is coming as V squared minus U squared? Because there will be two velocities. You need to remember this. One is initial velocity and one is final velocity. So when initial velocity you will be taking it as u, final velocity will be coming it as v. Understood? So always whenever we talk about work done is equal to delta kV, what is the meaning of work done is equal to, where work done is equal to delta kV? What is the meaning of delta kV? Kinetic ke, kinetic energy. That means half mv square minus half mv square minus half mu square. Understood? U square. U will be supposed to be the initial kinetic energy, and v will be the u will be the initial velocity and v will become the final velocity. That's the difference. I hope you might have understood, beta. So whenever change means the total energy, the total work done, someone will be asking what is the total work done, then what you are going to say? The total work done is final kinetic energy minus initial kinetic energy, and that will be delta ke. What it will be considered as? Delta ke. Delta ke, initial final kinetic energy minus final kinetic energy. Understood? I hope you might have understood beta. So here half mv square minus half mu square. So that is work done will be change in kinetic energy. So half mv square minus half mu square. So mass work done is equal to mas. So whenever you will be talking about, so v is a squared minus u squared. That's what now, because how we have done that one. If anybody will ask you that after this what you have done, then what answer you are going to give. Now I'm going to do this one. See, I'm going to derive the equation fully. Come on, check this one out. See, look at work done is equal to force into displacement. Done. After that, by Newton's second law of motion, force is equal to MAS. This is how, because of Newton uncle. Newton uncle said that force is equal to mass into acceleration. Now, first equation of motion, what they say, V minus U. So V square minus U square is equal to 2AS. This is our second or third equation. Second equation of motion. Our second equation of motion is v square minus u square is equal to 2as. So here v square minus u square by 2, it will be equal to as. So very cleverly you remove as. Now when you are removing as, what you are writing, v square minus u square by 2. So now it will become W is equal to half mv square minus half mu square. So it is coming W is equal to, this is final kinetic energy and this is initial kinetic energy. So it will become delta Ke. Delta Ke is change in kinetic energy. Come on, note down this one. क्या हुआ बोल? I hope till here it is done. Is it okay? Is this done? Packed? Done? Yes. Did you understood here? So that derivation you will understand or not understand, but what I did, you will definitely be. So definitely remember, every energy theorem is practically useful calculation for minimum stopping distance. If a body is brought to rest, the work done to do this equal to kinetic energy will be exactly lost. Okay. I hope you might have understood this one. Now, beta, we are going to do some work. Let's see. Potential energy. Okay, if somebody will be asking you what is the meaning of potential energy, what is the meaning of potential energy? What is the meaning of potential energy? Come on, do it. Potential energy is the energy possessed by a body due to its virtue of position. Understood not? By virtue of its position, anything which possesses energy has a capability to do work. When a hammer is lifted to a height, then allowed to fall on a nail of a wooden surface, we see that nail goes inside the wood. This shows that hammer gained some energy, which it was exactly lifted. So energy was required to drag the nail. So 100% the energy was required. Yes, stretched bow. Absolutely correct. Some error is there, beta. This show that the hammer gained some energy which was lifted. So this energy was required to drag the nail inside the wooden block. So definitely whatever potential energy was there, that potential energy got converted into what? Kinetic energy. So whatever energy was stored in the hammer, that energy is exactly getting utilized. Understood? So here now network is okay. Can you tell me? Is now the network is okay? Because here one error is written. I tried, but it is not going. Should see this, Sam? Is it there? Check. Come in here, check. See, some error is showing. Live, is it any problem? Error is written, na? So live, any problem is there, huh?
I think you're seeing in two devices.
No, this device I'm not operating. Don't know what happened. Check. It is not going. I tried a lot. Either more than one ingestion is using primary. Someone else is using.
Yeah, I think so. Because more than one injection.
Someone is using our device.
Yeah.
Who can be that person? Shall we continue?
It might be running in your phone.
No. In my phone, it is not there. I tried 2, 3 times. I tried 2, 3 times. I went inside, I came out, I went inside, I came out. It is showing 2, 3 primary ingestions are there. That means someone is.
Start the line again.
Hmm? Don't know. We will carry. Huh, I'm coming. Someone is just using our system, beta. It's not good. Ingestion is there. Some ingestion is there, which is exactly. Wait, after returning, I'm going to keep class. First, I need to check because this is not good. Our system is hacked. System is